Okay, series circuits. So I'll go through series circuits in this video. So just as a reminder, current is a flow of charge. So current is a flow of charge. Current has no choice in a series circuit. It can only flow however it does. And remember, it always flows from a positive to a negative charge. It always goes from positive to negative. That's my positive, that's my negative, so my electricity or my current will be flowing this way. So current in a series circuit, if I've got 4 electrons passing that way, those same 4 electrons will pass here, and those same 4 will pass here. Okay, it's not strictly speaking electrons, but to get you to understand, that's what it is. So if I've got 4 amps of current there, there's no choice, it has to carry on. So that means the same 4 amps of current will be there, which means 4 amps of current will be there, because there's nowhere for us to get rid of that current. So wherever it is there, it will be there and there. So potential difference adds up. So if I've got a potential difference, remember potential difference is measured with a voltmeter, and a voltmeter always goes on the outside of the circuit. So if I've measured my potential difference across my cell and it's 8 volts, it then goes round here and deposits 6 of those volts at this bulb. It would have 2 volts left at that light bulb before it went back round. It would then be given another 8 volts. It would go back round, 6 volts to that light bulb, 2 volts to that light bulb, back round again. If, let's say that this wasn't 6 volts, and I wasn't told anything at all, you would assume that because they're identical bulbs, they would split it 4 and 4. Okay, so if you're given no information, it's just split between the two evenly. The other option is you could get something where you get given like 3 volts there, in which case that would be 5 volts there. Okay, so it adds up, whatever it is there, it adds up on the next branch. So that's branch number 1 that has 8 volts. This branch total needs 8 volts, so it's 3 and 5, or 6 and 2, or 4 and 4. Finally then, resistance. So on this circuit here, if I've got electrons travelling through, or I've got current flowing, it hits 1 ohm of resistance there, 4 ohms of resistance there, 2 ohms of resistance there. It's hit a total of 7 ohms. Okay, because it adds up as it goes around. This one here, if I get to here and it hits 7 ohms, it then hits another 2 ohms, and I know that my total resistance is 15, I would do 15 minus 2 minus 7 to give me 6 ohms. Okay, so current is the same the whole way around. Potential difference adds up per component to whatever the total is, and resistance adds up as well. So that's series circuits.